Yeah, hi everyone, welcome to PrepFusion. So in this video, we are going to do a very interesting discussion on built-in potential. Okay, so just keep on watching this video. In the end, you will feel very good about it. Like something good we will surely conclude in the end of this video. So this PN junction we have already studied. If I need to find out the built-in potential between AB, so what will be that built-in potential, sir? You know that, sir, P side would be negative and N side would be positive. Why is that so? Because, sir, here this is the condition and here this is the condition. So this is the built-in potential that I'm writing down. But I always care about the magnitude of built-in potential. I already know the polarity. Polarity would be B side would be positive, N side would be, N side would be positive. That means this B node will be positive and A node would be negative. What is the magnitude that we get? So that would be KT ln NA by Ni square. Although here Na1 Nd1 is written, so I can write down Na1 Nd1 Ni square. Just keep on watching the video, something good we will surely conclude. If N plus and N junction is there, then N plus N junction. So now what will be the scenario? Sir, here there is positive, positive, and here this is the scenario. This doping is more, right? What is the meaning of N plus? That Nd2 is more than Nd1. Right? Just 1 second. I need to turn on the charger. Just 1 second. Yeah. So Nd2 is greater than Nd1. So you know that, sir, electrons from here will travel to the N side. What does that mean? This side would be more positive and this side would be less positive. So this side would become negative, this side would become positive. Although I don't care about the polarity, I only care about the built-in potential between AB. What that would be? Sir, KT ln higher electron concentration divided by lower electron concentration. Same goes for this one. Sir, this would be more negative side. Why it would be more negative? Because holes from here will travel here. What does that mean? What will be the polarity? So this would be more negative and this would be less negative. That means this would be positive, this would be negative. I hope you are understanding. 5 volt and 3 volt. How can you replace it? In this manner, 2 volt. Right? Very basic thing. Minus 3, minus 5. How can you replace it? This is more negative by the battery of 2 volt. Basic thing, right? This will be more negative, this will be less negative. So that's why I can replace it by a battery like this. Although I don't care about the polarity, but still somewhere we will be requiring the polarity. That's why I am making it. So what will be the built-in potential between A to B? I only care about the magnitude. So this also we have seen KT ln higher concentration divided by the lower concentration. So answer would be Na2 by Na1. So in all the scenario, what was the scenario? That semiconductor was there. One side you did the doping of P side and then one side you did the doping of N type. Then here you did the doping of N plus, here you did the doping of N. Here you did the doping of donor acceptor concentration but more amount. Here you did the doping of acceptor concentration in less amount. Now what you are doing? You are taking one semiconductor. One side you have doped acceptor concentration of some certain amount. Then again you have did the doping of acceptor concentration but more amount. And then again you have done the doping of donor concentration in a decent amount. So what is the scenario here? Sir, here this is the scenario. Now there is a scenario of this one. And then, sir, this is the scenario. Here also I will write down the same thing. So basically there are two kind of junction. This is one junction and this is another junction. Two junctions are there in this scenario. Now can you make the polarity? What will be the polarity? Sir, this side would be more negative. Why is that so? Sorry. This side would be more positive because holes will travel towards this side. We have already seen P plus and P. So P plus was, here we saw, P plus was more negative and P was more positive. So if I make the battery, what kind of battery I will get? It is very simple, right? Holes will travel here. So this particular side will become more positive, this particular side would be negative. So if I make the battery in this manner, I can make the battery. Let's just say this particular side is A and this particular side is B. Okay. So this side is A. Then in A, from P side you can make positive battery and then here you can make negative battery. I am calling this as V built in 1 because this is your junction 1. Then another junction is there, no? Here what will happen? Electrons will travel, holes will travel towards this side and electrons will travel towards this side. So another battery would be made. What will be the polarity of the battery? So this side would be negative and this side would be positive. So between A and B, two kind of built-in potentials are there. But one is having this kind of polarity, other one is having this kind of polarity. If I find out V built-in potential between AB what that would be? VB1 minus VB2. Say yes or no. VA minus VB1 plus VB2. What does that mean? Simply means that if one I am taking positive, the other one I need to take a negative, but I always care about the magnitude. So what I am doing, I am finding out the built-in potential between AB. This is the task that I am doing. So I will write down V built-in 1. What that would be? Can anyone let me know what will be your V built-in 1? So that would be KT ln higher concentration divided by the lower concentration. So basically this particular battery can be replaced by this. What about V built-in 2? Sir, KT ln. This would be ND1 Na2 divided by Ni square. So this particular battery can be replaced by this, right? This battery can be replaced by this. This will also be a positive value. This will also be a positive value. So this kind of polarity you are getting. If I find out V built in AB, what that would be? And like it would be simply subtraction of both of them. Like this particular thing can be subtracted from here, or this particular thing can be subtracted from this one. Basically, I need to subtract both of them. So what you will be getting? Sir, KT can be taken common. ln Na2 Na1, and since you are subtracting, then what you can see? Ni square will go upward, Nd1 Na2. So what you can see here, Na2 and Na2 will get cancelled out. So you are getting, sir, KT ln Ni square Na1 Nd1. But you know that Na1 Nd1 would be higher than Ni square, right? Basically, Ni square would be lesser than Na1 Nd1. But what I need to do, I need to write down positive value. So eventually, can I write down the answer as KT ln, if I am only talking about the magnitude. So KT ln Na1 Nd1 divided by Ni square. Did you understand this point? Simply I subtracted both of them, nothing else. I was actually getting this answer, but I need to write down the positive value, right? Because I know that doping that I have done, Na1 would be surely greater than Ni, Nd1 should also be surely greater than Ni, then only you would call it P type, then only you would call it N type. So this particular value will be higher than this particular value. That's why this value will be negative. To make it positive, I have written Na1 Nd1 divided by Ni square. Is that understandable to you? Very simple thing, right? So what is the answer you are getting? Built-in potential between A and B you are getting as KT ln Na1 Nd1 divided by Ni square. Do the same thing for this particular scenario. In this scenario, what will happen? So this side would be negative, this side would be positive. And what about this one? This side would be positive, this side would be negative. Say yes or no. You can understand it. Here plus would be there. Here this scenario would be there. Here plus would be there. And here this scenario would be there. Right? So this side will be negative, this side will be positive, this side would be positive, this side would be negative. Again, both are being subtracted only. So what will be your V built in 1? KT ln Na1 Nd1 divided by Ni square. And what will be your V built in 2? So that would be KT ln Na2 Nd1 Na2 Nd1 Ni square. Okay, subtract both of them. That would be your V built in between AB. If I subtract both of them, what will happen? Ni square will go upward, Nd1 will get cancelled out. Answer we are getting as Na2 divided by Na1. I always care about the magnitude. So ln higher concentration divided by the lower concentration. Now look at the answers very carefully. Whatever the answer that you are getting, look at them in a careful manner. KT ln Na1 Nd1 divided by Ni square. KT ln Na2 by Na1. Here you are calculating the built-in potential between these two guys. So the node A is connected to P and node B is connected to P plus. In the final answer, what you are getting? Na2 divided by Na1. Node A is connected to P. Node B is connected to N. In the final answer, what you are getting? Na1 Nd1 divided by Ni square. So effectively, what do you see here? Only the last two guys are a matter of concern. whatever that is added inside, that is not a matter of concern. Basically, if I was having PN junction, then what would be my answer? If I was having PN junction, my answer would be Na1 ND1 divided by Na square. Na1 ND1 divided by Na square. So where I have connected the node, this node is connected to P, this node is connected to N. They will be my matter of concern. Here I have connected the node to A, here I have connected to node B. So P and P plus, that will be my answer. Na2 divided by Na1. So for P plus, what will be my answer? Na2 divided by Na1. Is that understandable to you? So no matter if I take a very big semiconductor, here I did no matter what kind of doping. But eventually if I say this is P plus and this is P, here intrinsic concentration I can write down, here N plus I can write down, N plus plus I can write down, no matter metal I am writing down here, but I am asking between this guy and this guy. What will be the answer? KT ln Na2 divided by Na1. Let's just say I am asking between this guy and this guy. This is my A and this is my B. I am asking built-in potential between A and B. What will be the answer? Sir, for Na plus the doping is Nd2. For Na plus, for this N plus the doping is Nd2. So what will be the answer? Sir, KT ln Na1, or this is Na2. So Na2 Nd2 divided by Na square. That means your effective junction would become P plus and N plus junction. If I ask you between this guy and this guy, if I ask you between A and C, then your effective junction would become P plus and N plus plus. Are you able to understand this point? So 2 points where you are finding the built-in potential, that would be your matter of concern. Nothing else would be your matter of concern. We will prove it with respect to energy band diagram as well. So the same thing I am going to prove, but this time with respect to energy band diagram. But as of now, here also you can see that only last two guys where we are calculating the built-in potential, these nodes are connected to N, this is connected to P. So effectively PN junction is a matter of concern if I want to find out the built-in potential. This is A, this is B. Effectively P plus is a matter of concern if I want to find out the built-in potential. Let's understand the same scenario with respect to energy band diagram as well. So what is our condition? That there was this semiconductor. In this semiconductor, here I did the doping of P plus, then I did the doping of N, then I did the doping of N plus, and then I did the doping of P. Here what do you know? That sir, surely Na2 is greater than Na1. That's why I call it P plus. And surely, sir, Nd2 is greater than Nd1. This is something that I already know. Now let's make the energy band diagram. From energy band diagram, we can conclude something pretty good. So where will be EFI? EFI would be somewhere in between, right? So EFI, I don't care about it. EFI I will erase later on. But as of now, first, what we need to make? P plus. For P plus, my Fermi level will be nearer to, this is my conduction band and this is my valence band. So my Fermi level will be nearer to the valence band. For N, my Fermi level will be nearer to the conduction band. Here I am making it, right? For N plus, my Fermi level will be nearer to the conduction band, but here doping is more, so I will make it here, right? And for P as well, the Fermi level will be nearer to the valence band, but I will make it here. Why here? Because here the doping is more. Is that understandable to you? Very simple thing. Okay. So now I have made it. Now you know that at equilibrium, what will be the condition? Let's make it in a better manner. Now let me know what will be the condition at equilibrium. Okay. At equilibrium, all of them will come on the same line, right? All of them has to come on the same line only, no? Right? This is the meaning of equilibrium. At the equilibrium, there will be zero current. If there is zero current, that means Fermi level will be flat. If you want to maintain the flat Fermi level, so let's just say I am saying that this guy is not moving. Then how these people will move? This guy will go upward, this guy will come downward, and this guy will come downward. I am saying that this guy is remaining at his own place. So what you will say? This guy will go upward till this point. This guy will come downward till this point. This guy will also come downward till this point. So basically, effectively what will happen? Let's check that. What I need to do is that I need to maintain this particular condition. Basically, everything should be in the line of this guy only. Everything should be in the line of this guy. That means this particular guy needs to come down. This particular guy also needs to come down. So now you can see that now this has become my effective Fermi level, right? So what kind of energy band diagram I will be getting? This kind of energy band diagram I will be getting. Effectively, this will be my energy band diagram. Say yes or no. Effectively, this is your energy band diagram. And this is my Fermi level. This is your Fermi level at the equilibrium. Say yes or no. Okay. Now what I am calculating? I am calculating built-in potential between these two guys. So initially they were at the same level. This EC and this EC was at the same level. But now they have been disturbed by how much amount? They have been disturbed by this much of amount. How much of amount? This much of amount. Say yes or no. Previously, EC both were the same semiconductor. Everyone was at the same level. But just as you join them, one guy went up, other guy went down. That means there was some gap that came into action, and this was only your built-in potential. This was only your QV built-in between A and B. And what would be that gap? That gap would be nothing but KT ln Na2 divided by Na1. Say yes or no. If I wanted to calculate built-in potential between this guy and this guy, basically if I wanted to calculate built-in potential between A and C, then what would be the answer? This would be the answer. If you have followed the first lecture, then you will be able to understand all these points. Okay, this would be the answer. By the energy band diagram we are understanding it. What that would be equivalent to? QV built-in between A and C, and that would be equivalent to KT ln Na2 and D1 divided by Ni square. Are you able to understand this point? So the 2 points where we are calculating the built-in potential, only they are the matter of concern. And you can check as well, if P plus and P junction was there, P plus and P junction was there, nothing was there in between, then what would have been the scenario? Let's check that again. Okay, this is your A, this is your B. So where will be your intrinsic level? Intrinsic level will be somewhere in between. This would be my EFI, this would be my EFI. Where will be my conduction band? Sorry, where will be my Fermi level? This would be your Fermi level, and here this would be your Fermi level, right? Now at the equilibrium, they need to maintain the same space. That means this guy can come downward. So if they are at the same place now, previously this is the condition. Now this guy needs to come downward. So basically, previously what was this distance? This distance was KT ln Na2 divided by Ni, right? Na2 divided by Ni. And then what was the distance here? This distance was KT ln Na1 divided by Ni. Now what will happen is that this particular guy will come downward, right? This particular guy, I am saying that he is not moving, but he is moving. So he will be coming downward. What does that mean? From here he is coming downward. So can you visualize how much distance he has traveled? From this particular condition, he will come downward. That means he needs to follow this much of distance. So this much of distance, what will happen is that this guy will come downward, right? And the same distance it would have traveled here. So this will be my built-in potential. Like if you have followed the previous lecture, there I have given the complete explanation of all these things. I hope you are able to relate built-in potential between A and B. So what was that distance? Previously what was the scenario? Sir, previously this was the scenario. Previously, sir, this was the scenario. Then it will travel this much of distance. Can you find out what is this much of distance? Can you find out what will be this much of distance? Sir, this total distance minus this distance. So what will be my QV built-in between A and B? So that would be nothing but KT ln Na2 divided by Ni minus KT ln Na1 divided by Ni. So that would come out to be KT ln Na2 divided by Na1. So we are getting the same answer here as well. We are getting the same answer here as well. So that means the 2 points that are connected, they will be our matter of concern. Is that understandable to you or not? A very, very interesting point. Okay. So this kind of questions they can ask any day. What they have given, that there is a semiconductor, this kind of doping profile I have done, P, P++, N+, N, I and P. I means intrinsic. You need to find out the magnitude of built-in potential between AB, AC, AD, AE, AF, or they can ask between CD as well. Whatever, any random 2 points they can ask. Is that clear to you? Okay. Ni value is given 10 to the power 10. doping concentration are also given. So let's just say if they have asked me built-in potential between AB, what will be my answer? Those two who are connected, they will be my matter of concern. So KT ln 10 to the power 17 divided by 10 to the power 14. I only care about the magnitude. I only care about the magnitude. So what will be the answer I will be getting? 0.026 ln 10 to the power 3. So you can calculate it. As of now, calculation is not my matter of concern, right? What about built-in potential between AC? So what will be your built-in potential between AC? Sir, N plus and P. So KT ln NAND by NI square, right? Because for PN junction, this is the formula of built-in potential. How this formula came, that also we have understood. Already we know it from the previous lectures. So 10 to the power 16 into 10 to the power 14 into 10 to the power 14 divided by NI square. That would be 10 to the power 20. So what will be the answer? 0.026 ln 10 to the power 10. Between A and D also you can find out. V built in between AD. What that would be? KT ln 0.026 between A and D. This is N and this is P. So 10 to the power 14 into 10 to the power 14, that would become 10 to the power 28 divided by NI square. That would be 10 to the power 20. So answer is 0.026 ln 10 to the power 8. Okay. V built in between AE. AE. So this is intrinsic. Okay. And this is your P type. Intrinsic and P type. What do you think? What will be the answer? Let's make the energy band diagram if you are not able to understand. Let's make the energy band diagram for PI. Whenever you fail, always energy band diagram will be coming to the rescue. AE. So what will be the energy band diagram of P type? Sir, conduction band, valence band. Here, sir, conduction band, valence band. Here, where will be the Fermi level? Right in the middle. Here, where will be the Fermi level? Sir, near to the valence band. Right? So, sir, EC, EV. This was the Fermi level here. But here the Fermi level is right in the middle. You call it intrinsic Fermi level or whatever you call it. Now, what you need to do? Sir, these guys two will be flat. Right? These two guys will be flat. What does that mean? That means this guy needs to travel this much of distance. What is this much of distance? Sir, that will be equals to this much of distance. That means what is this distance? Sir, this distance is nothing but distance between EFI and EFP. So what will be the answer? Sir, that would be KT ln NA divided by NI. Say yes or no. Right? Very simple. Basically, both will be flat. No, that means this guy needs to travel this much of distance. He will come downward. So how much distance he traveled? This much distance he traveled. This is your intrinsic Fermi level only, and you call it Fermi level as well, whatever you want to call it. So what is the gap between Fermi level and intrinsic Fermi level? That is KT ln NA by NI. So what will be the answer? KT ln NA by NI. That's it. Or you could have said whole concentration here divided by whole concentration here. What is the whole concentration here? That is equals to NI only. And what is the whole concentration here? That is equals to NA. Because in the intrinsic semiconductor, whole concentration equals to electron concentration equals to Ni. So whole concentration here equals to whole concentration here. What is the whole concentration here? Ni. What is the whole concentration here? Na. Na divided by Ni. What is the value of Na? 10 to the power 14 divided by Ni. So what is the answer we are getting? 10 to the power 14 divided by 10 to the power 10. So answer would be 10 to the power 4. Okay. So wherever you are stuck in the whole chapter, I'm not only talking about PN junction. In the whole EDC, wherever you are stuck, get the help of energy band diagram. If you are comfortable enough with the energy band diagram, there is no one who can stop you. Okay. Between A and F, what do you think? What will be the answer? Between A and F. Sir, KT ln 0.026 ln P versus P, 10 to the power 14 versus 10 to the power 14. What will be the answer? 0. If same material is there, what will be the answer? 0 only. No. Just think about it. P versus P. Same kind of doping is there. That means it is P type semiconductor. Right? There will be no diffusion. If there is no diffusion, that means no negative charge is losing its whole. So no diffusion, nothing. So no built-in potential. So 0 built-in potential. Between A and F, 0 built-in potential. Now they could have asked between two random guys as well. What would be two random guys? they could have asked between, let's do it between C and E. So what will be the answer? If they have asked, let's not do C and D because it is intrinsic. So let's do C versus D. If they asked between C and D, what will be the answer? So 0.026 ln n plus n. So 10 to the power 16 divided by 10 to the power 14. Answer would be this much, right? What if they have asked between B and E? B and E is nearly same as A and E. So let's do between C and E. C and E. So what do you think? What will be the answer? 0.026 ln electron concentration here. What is the electron concentration? 10 to the power 16. And here what will be the electron concentration? That would be 10 to the power 10. Right? Electron and hole both concentration are same. So here it will be 10 to the power 10. So 10 to the power 16 divided by 10 to the power 10. Or you can simply write down Nd divided by Ni. So that would come 0.026 ln 10 to the power 16 divided by 10 to the power 10. That would become 10 to the power 6. Right? Between C and E. 10 to the power 6. So is that point clear to you? So what did you understand? If you find out the built-in potential between two same kind of semiconductors or two same kind of material, this material and this material was same. If I find out the built-in potential between two kind of same material, my built-in potential will come out to be 0. Now I will answer your question that when I use a voltmeter to determine my built-in potential, why my reading is always 0. Like basically this question I have been asked a lot of time that the built-in potential for measuring the built-in potential, what we did? Sir, we draw the graph of 1 by Ct square versus reverse bias. Reverse bias will be taken in this direction. Then we draw this graph and then we increase the graph backward, and where it cuts, that will be my built-in potential. This is what we do. Sir, why we cannot measure it using voltmeter? So at a lot of places what I have heard, they say that built-in potential is an internal parameter. Okay, it is an internal parameter. So you would not know where is the built-in potential. So you cannot actually measure built-in potential. Like this is the explanation I have heard at a lot of places, that built-in potential is an internal parameter. So where you will connect the voltmeter, you will not be able to understand the built-in potential. That's why you can never measure it through voltmeter. Absolutely baseless. Basically, if I am saying that built-in potential has been developed at this point only, between these two guys only. So what did I tell you? That wherever the built-in potential has developed, apart from that, if built-in potential has been developed in this much of region, apart from that, all the region is neutral only. No, this region is neutral. This region is neutral. So what I can do? I can simply connect the terminal here and I can simply connect the terminal here. So whatever the potential that I was getting here, the same potential will be reflected here as well. Now let's just say in between I was having 0.2 volt. Then this particular region is simply short circuited. This particular region is also simply short circuited. And if I ask you what is the potential between these two guys, what you will say? 0.2 volt only. So you are saying that, sir, like built-in potential is an internal parameter. So I will not be able to find out where is the built-in potential. You don't need to find out where is the built-in potential. You take two terminal, connect one terminal here, connect one terminal here. At the edge of PN junction, like this is the, let's just say this is my PN junction I am having. One I will connect here, other one I will connect here, and I will simply measure what is the voltage I am having. So the explanation that built-in potential is an internal parameter, that is absolutely baseless. Okay, even if it is built-in, even if it is a built-in parameter, it doesn't mean you cannot measure it. You can measure it with voltmeter, but when I am using the voltmeter, what is the problem I am facing? So this was my PN junction. I connected a voltmeter. Now you would have seen the voltmeter, or I might be having, I am not having voltmeter, I am having the multimeter. Okay. So there will always be some metallic probes, right? These metal would be there. Like let's just say this is my PN junction. So what I would do, I would connect this metal here and I would connect this metal here, and then I will measure the voltage, right? So what is this? Metal. This is my N-type semiconductor. This is the metal I am having, and this is my N-type semiconductor I am having. So there is a junction made between metal and N-type semiconductor. No, similarly, here also there is a junction made. So effectively what you wanted to calculate, you wanted to calculate the built-in potential between these two guys, where let's just say this node was A, this node was B. But actually what you are doing, you are calculating the built-in potential between C and D. Is that clear to you? This was my PN junction. I connected the metallic contact here. Between metal and semiconductor there was a junction made. I wanted to calculate the potential between A and B, because whatever the built-in potential is there, that is equals to, like, VAB is equals to V built-in only. What I am saying is that VAB is nothing but V built-in only. V built-in only. Do you agree to this point? Yes. VAB is nothing but V built-in. But I am not calculating V built-in. If I am using the voltmeter, these probes will have some metallic contact. I am effectively calculating VCD. Now, can you let me know what is the potential between C and D? Sir, the built-in potential, or whatever potential you say, between C and D would be, sir, KT metal divided by metal. Metal electron concentration or hole concentration divided by metal electron concentration. So metal concentration divided by metal concentration. And both will be same kind of metal. Even if they are different kind of metal, your reading would be different. But effectively what you are doing, effectively you are calculating the potential of metal versus metal. This is what you are doing. Because I told you, if there are different kind of junctions, here there were different kind of junctions. But because whatever the point that we are interested in, if we are interested in between A and B, then effectively we are assuming P and P plus junction. If we are interested in A and D, effectively we are assuming P and junction. So if we are interested in C and D, so I would see that C is connected to metal and D is connected to metal. So we are effectively calculating the built-in potential between metal and metal. It might happen that this is having different kind of electron concentration, this is having different electron concentration. That is not a matter of concern. But what I actually wanted to calculate, I wanted to calculate the built-in potential of PN junction. But I am ending up calculating the built-in potential of metal and metal, which is absolutely wrong. So that's why using the voltmeter, you can never measure the built-in potential. Saying that this is an internal parameter, you would not be able to know where is the built-in potential, absolutely baseless. Doesn't makes zero sense, or I should say it is making sense in negative direction. Okay, so never ever say, if these kind of questions are asked in ISC interview or in some good interview, so never ever say that, sir, it is a built-in parameter, we will not be able to see. We will use the voltmeter. What we will do, we will use the metallic contact. These metallic contacts are there. If I am measuring the, what I wanted to calculate, I wanted to calculate built-in potential between P and N. But effectively what I am making, I am calculating the built-in potential between metal and metal. It might happen that both are having different electron concentration. It might happen. But eventually what I am calculating, this is the built-in potential. I wanted to calculate between P and junction, but effectively I am calculating between metal and metal only. That would be a wrong answer. But what would happen is that, like, both of the metal would be of same material, right? Like, this is one probe, this is another probe. So both are having the same material only, no? So it would come out to be 0. Okay, so in a lot of textbook you would find out that if you use a voltmeter, the reading would come out to be 0. Why it would come out to be 0? Because both will be same material. If they are different material, then answer would be different. Okay, let's just say this is a better conductor and this is a, like, this is a better metal and this is less better metal. Let's just say this was having 10 to the power 40 free electrons and this was having 10 to the power 38 free electron. 10 to the power 38. So answer would be KT 10 to the power 2. But both will be same material. Okay, so answer would come out to be 0. So let's not write down 0 here. Okay, I will erase the 0. I will just write down KT material concentration divided by material concentration, which is not equals to V built-in of PN junction. Is that clear to you? So this is actually a very famous question of interviews, that why you need to draw the 1 by CT square versus V plot, VR plot for getting the built-in potential. Why you cannot measure it through voltmeter? And I have seen people saying it is an internal parameter, that's why we will not be able to calculate it. But absolutely baseless. Okay, well and good, all fine. Yeah, so that's it. This is the end of this video. I wanted to give you this concept, like these kind of questions can also be asked, and this kind of question can also be asked in the examination. Like, they can make any random junction, then they can ask you built-in potential between any two guys. So what you need to see, where I am having the nodes. So that particular node is connected to what? Here. This particular node was connected to D. This was connected to A. So PN junction is my matter of concern. This was connected to C. This is connected to A. So PN plus is my matter of concern. This is connected to B. This is connected to E. Then P plus plus I is my matter of concern. Say yes or no. I hope this discussion was good. And with that, we have ended our PN junction. Okay then. Yeah. Thank you very much. Happy learning.